In this video, I'm going to show you how to divide polynomials. And I'm going to show you two different methods, the long division method and the synthetic division method. So to start off, we're going to take a look at long division. And we're going to start off with something that should be familiar. We're going to try to divide 83 by 3. And I know it's not going to divide evenly, but we'll get there. And since we're trying to do this long division, we're going to pretend that our calculators are running out of batteries and we don't have access to it. So, start off, just kind of remember reformatting it like so. So I got 3 divided by 83. 3 goes into 8 2 times. Gives us 3 times 2 is 6. Subtract. 8 minus 6 is 2. Bring down to 3. So how many times does 3 go in 23? It goes into it 7 times. 3 times 7 is 21. And I'm left with 2. And 2 is my remainder. Now we can use the method and go on and get the decimals and stuff like that, but for this particular exercise, we're just going to leave it with a remainder of 2. So 3 divides into 83 27 times and gives us a remainder of 2. And we're going to take that kind of same idea and we're going to apply it to polynomials. So let's take a look at this guy. So we want to divide 2x cubed plus 5x squared minus 4x minus 5 divided by 2x plus 1. So same idea. We have our dividend, our divisor, and we're trying to find the quotient. So I'm going to rewrite this just like before. So I have 2x plus 1, and it's 2x3 plus 5x squared minus 4x. Minus 4x minus 5. So right off, I'm just kind of looking at this kind of first term, this 2x. And looking at the first term over here, it's 2x cubed. So I have to think about something that I have to multiply 2x by to get 2x cubed. Well, and that's just 1x squared. So 2x times x squared gives me 2x to the third. 1 times x squared gives me 1x squared. So now I'm just going to do the exact same thing. I'm going to subtract. 2x to the cube minus 2x to the cube is 0. 5x squared minus now 1x squared is 4x squared. So I'm just going to kind of repeat this pattern. And I'm just going to bring down this guy, negative 4x. So now I'm looking at 2x again, and I'm looking at 4x squared, so 2x times 2x, well, that's going to give me 4x squared. And 1 times 2x gives me 2x. So brackets around it, and I'm just going to subtract the top from the bottom again, and just doing the terms. 4x squared minus 4x squared is 0. Negative 4x minus 2x gives me negative 6x. Again, bring down the 5, just like before. So now I'm at near the end. Now I got 2x and 6x. Well, the only thing I can use is negative 3. So negative 3. So 2x times negative 3 is negative 6x. 1 times negative 3 is negative 3. Subtract them. Negative 5. Now, minus 3 is 2. Negative 2. And that is my remainder. So, again, we don't kind of go on, but we just kind of like leave it with the remainder. So, 2x plus 1, and then divide it into 2x cubed 5x squared minus 4x minus 5 will give me this kind of quadratic x squared plus 2x minus 3, but also give me a negative 2 remainder. So that's kind of the long division format. And we use just the same way we learned back in elementary school how to do long division by hand. And now we just kind of make sure that the terms match up here, and here, and here, and then just kind of bring down the numbers as we go. So hopefully it works out. We don't have a remainder, which means it's a factor, but sometimes we're just left with it and just go from there. So let's take a look at another example. So let's take a look at this one. x cubed minus 5x squared minus x minus 10 divided by x minus 2. And now for this one, I'm going to show you the synthetic division. Now we can do synthetic division only if we have this kind of x minus k kind of version. So that means we have just one beside the x and then kind of whatever k is here, but it's going to be the kind of the opposite sign. So here we have x minus 2. So we put the 2 right here, and we just kind of draw this little kind of half bracket. And then I just put the coefficients for each of the terms here. So we have 1 for x cubed, negative 5, negative 1 again, and then negative 10. So from here, we just kind of bring down the 1, and then I multiply 1 by my kind of number here, 1 by 2. And that goes here. So 1 times 2 is 2. Now here's where it gets a little different. Now we add. We don't subtract, we just add. So negative 5 plus 2 gives me negative 3. And then I just do the same thing. I multiply by this 2 here. So times 2 and bring it here. So negative 3 times 2 is actually going to be negative 6. So minus 1 plus minus 6 is negative 7. So we just kind of go from there. So we keep on moving it. And we got negative 7 times 2 times 2. And that's going to be negative 14. All right, so we got negative 10 minus 14, and that gives us negative 24. And this kind of last kind of one is our remainder. So this is the remainder kind of box. So we're able to divide it kind of like this by this other method. Some students find this actually a lot faster and it's easier to conceptualize, but there's just a couple points here. It has to kind of be like just 1x minus whatever. And also, instead of subtracting like we do with long division, we have to add. So minus 5 plus 2 is negative 3, and not the reverse as our long division says. All right. So those are the two methods. So we have the long division method, and then we have this kind of synthetic division method. And just practicing those, you'll be trying to figure out which way works best for you. And both ways are fine. You should get the same answer no matter what. So let's take a look at this one. And this one I'm going to do with the long division method because, well, I got this x kind of squared term. I can't really resolve that. So you also notice now that I have 5x minus 2x3 plus 4x. So the terms are actually all out of order. So what I'm going to do is I'm first going to just go x squared plus 2x plus 1. Put that there. And then I'm going to put the rest kind of in order. So x4 is the biggest term. And then minus 2x3. And then x squared. I don't have any x squared terms, but I still have to account for that in my division. So I have to just put a little, I just put plus 0 x squared. So I still have to account for that space in that term. And then I just kind of put the rest. So plus 5x and plus 3. So just to kind of continue it off. And I'm just going to do this the exact same way as I did before with the long division. So I have x4, x squared. Well, x squared times x squared gives me x to the 4. 2x times x squared is 2x3. And I have 1 times x squared plus 1x squared. So again, subtract them. x4 minus x4 is 0. Negative 2x cubed plus minus 2x cubed is negative 4x cubed. And 0 subtract 1 is negative 1x squared. Again, bring down the 5 plus 5x. And this is why it's important to keep that space for the 0x squared, because it kind of puts everything out of order, or at least the terms out of order. And so now I got a new kind of trinomial term. So x squared and minus 4x cubed, well, I'll have to multiply that by negative 4x. So now I get negative 4x cubed. 2x times negative 4x is negative 8x squared. And 1, negative 4 is negative 4x. Subtract both sides here. So negative 4x cubed, 0. Negative 1 minus 8 is actually going to give me positive 7x squared. 5x minus 4x gives me plus 9x. Again, bring down the 3. Okay. And now we got 7x squared. Well, 7 now becomes my number here. So now I got negative 7x squared. 2 times 2x is plus 4x. And 1 times 7 is 7. So in the end, I'm going to get this kind of linear remainder. So 0, and then I'm going to get negative 5x minus 4. And this whole thing, that is my remainder. So if I start off with dividing by trinomial, I'm not going to get like a number or a single digit as my remainder. I'm now going to get like a linear remainder, which will come in handy later on in the course. But like right now, we're just going to kind of leave it as it is right there. So we're just going to talk about 2 more things before we go. We're going to talk about what's known as the factor theorem and remainder theorem. Now, if I go back to this question, I have x3, 5x squared minus x, and I get this like kind of negative 24 remainder. All right, that's fine. But if I use the remainder theorem, I can actually kind of figure out what that remainder is. And I'll show you what the remainder theorem is in a second. If I do f of whatever k is, whatever this kind of k value is here, that's going to give me what my remainder would be. So whatever number k is, if I put that in for x, or substitute that in for x, that's going to give me my remainder, and I'll show you right now. So my f of x here is x cubed minus 5x squared minus x minus 10. So now my k in this case is 2. So I go f of 2. So that's going to be equal to 2 cubed minus 5 times 2 squared minus 2 minus 10. And when I do this all out on my calculator, 8 minus 5 times 4 is 28. Minus 2 minus 10, I'm actually going to get, lo and behold, negative 24, which is exactly what my remainder was originally. So that's the remainder theorem. Now, the corollary with the remainder theorem is if I do f of k, whatever k is, but my remainder is 0, that tells me that x minus k will be a factor of the function. So x minus k will be a factor of the function. Show you what we'll expand on that in a second. So going forward, we want to factor this, but I haven't given you anything to divide by. So that's where the factor theorem comes in handy. So we take this and we just put it into f of x cubed plus 6x squared minus x minus 30. Now, what I want to do is I want to find a number for x where it's going to be 0, where everything's going to be equal to 0. So we start off small. Let's start off with 1. So we go f 1, go 1 cubed plus 6 times 1 squared minus 1 minus 30. Well, it's going to be 1 plus 6 is 7 minus 1 is 6 minus 30. That actually gives me negative 24 again. But that's not 0. So I can't really use 1. So let's use, okay, let's use 2. Let's use f of 2. Let's go to the next number. Easier when it's positive. So we're going to say f of 2. So we got 2 cubed plus 6 times 2 squared minus 2 minus 30. All right, so 2 cubed is 8 plus 6 times 2 squared is 24 minus 2 minus 30. Oh, look at that. That equals 0. So this is telling me that x minus 2 is a factor of f of x. So it's telling me right away I got now one factor for this. So I got one factor for this particular function. So that's good. Once I got one factor, now I can divide. And for this one, I think I'll do synthetic division again. So we have, let's split it up. So 2, because I figured it out. And I'm going to go back up here. So 1 and 6. So I got 1, 6, minus 1, and then minus 30. So bring down the 1. 2 times 1 is 2. 6 plus 2 is 8. 2 times 8 is 16. That gives me 15. 2 times 15 is 30. Minus 30 plus 30 gives me 0 remainder. Great. So what does this all mean? Well, this is now just the coefficients for the terms. This just means x squared plus 8x plus 15. So that's actually, when I divided, that's my answer. So this gives us actually a trinomial that we can factor further. So x squared plus 8x plus 15 can be actually factored into x plus 3 and x plus 5. So now I got all three of my factors. So we know now that f of x also equals to the factors x minus 2, x plus 3, and x plus 5. So that's how we kind of use our remainder and factor theorem to kind of factor a polynomial where we don't even have any clue at the start what to do. So it takes a little bit of guesswork at the beginning, but once we find the one factor using factor theorem, we can then divide and find the rest of the factors.